Aira, Irsyad, Aiman, Nafdib, Nurin, Putri Dania, Rashdan Jeffrey, Sophia and also Umi Najiha. Hopefully you have a very eventful school holidays walaupun kita stay at home, but as long as we are safe and happy with our family, that should be our priority lah kan. So anyway, let's update our attendance first. But don't worry, if you miss the first slide, I will always give to you the attendance link later during the class, yeah. So don't worry. Okay, so jom kita mula discussing about a new chapter today, which is radioactivity. I plan to do revision on Friday. So for today and for tomorrow, we will discuss chapter 8 first, and then we will do a bit of a revision on Friday. As you might have read before, the format for our exam next week is only objective questions, 30 questions, and it includes chapter 1 to chapter 6 form 3 and a bit of a mix between a few subtopics in form 2. So I've listed out the topics in Telegram. So for those of you who didn't know about this, you can check out our Telegram later, yeah. Alright, so let's take a look. Sekejap ya. Okay, I have to change host control first, since quite a number of you are going to enter during class. Alright, let's start. So let's observe this video first, which introduces a good introduction for application for radioactivity, ya. Okey, kita tengok dulu.
How do we know how old something is? For people, we'd ask to see their birth certificate. For trees, we'd count the rings. But how do we know how old a fossil is? Fossils have their own internal clock. Scientists can read it by looking at the ratio of two different types of carbon atoms. Of course, every living thing is made of carbon. Plants grab carbon dioxide from the atmosphere and use it to form complex organic molecules. Animals get their carbon by eating these plants. But there's more than one form of carbon. Most carbon atoms have 6 protons and 6 neutrons. We call this carbon-12. High up in the atmosphere, sometimes cosmic rays hit nitrogen atoms. This creates carbon with 6 protons and 8 neutrons. We call this carbon-14. Carbon-12 and carbon-14 behave alike, but carbon-14 has one unique and important attribute. It's unstable. So once an animal dies, the carbon-14 in its body will start to go away. Every 5,730 years on average, about half of the carbon-14 atoms will decay into nitrogen. This is its half-life. After one half-life, the animal will have about half the amount of carbon-14 it started with. After another half-life, it will have about a quarter. And after another half-life, it will have about an eighth. By contrast, the amount of carbon-12 it has in its body will stay the same. By measuring the ratio of carbon-14 to carbon-12, we can measure how many thousands of years have passed since the animal died. Carbon dating works for fossils up to about 60,000 years old. For older fossils, scientists use unstable elements that have much longer half-lives. For Scientific American's Instant Egghead, I'm Michael Moyer.
Okay, so based on the video that you have just watched just now, what are the things that interest you? What are the things that make you want to learn more? Atau what are the things that make you question? Atau the things that make you want to read up more? Alright, let's see. Sekejap ya. Okay. So, okay, ada yang berminat nak tahu carbon dating methodology. Oh, that is good. Alright. Okay, so thank you for your responses. Yes, the video shows carbon dating using carbon 14 and compare it to carbon 12 as a guide to understand atau to identify, to determine which period or in what timeline the fossil or an artifact comes from. So we know that when if we learn chemistry, we know that carbon 12 is a highly stable atom, but carbon 14 is not. So carbon 14 will decay over time. Because of this, scientists can estimate the age of a certain fossil or a certain artifact. However, as mentioned by the video, if the fossil is much older than more than 16,000 years, a different atom will be used, a different element will be used to estimate a fossil or an artifact's age. So this is one of the application for radioactivity that is seldom discussed whenever we talk about radioactivity lah. Usually we talk about gamma ray, and then we talk about X-ray because of the Avengers and so on. So this is a real life application. When you will become archaeologist, you are not only talking about sociological aspects of previous culture or previous animals, but you also use science to provide a better understanding regarding previous culture, kan? Okay, so please refer to pages 232 and 233 in your textbook. These are the 4 personalities that is prominent in the history of radioactivity. Can you name these individuals? What are their findings? Okay, can you name these individuals and can you state what are their findings? Okay, let's see here. Alright, so what do you think, Sophia, Aiman, Nafdi, Lufaikal, what do you think? Siapakah orang-orangnya itu? Okay, the last 2 personalities tu dia suami isteri ya. Yes, very good. Okay, ada yang dah dapat. Okay, yes. The first, dia tukar colour ya. That is very nice. That is very thoughtful of you. Very interesting. Thank you, Nuri. Good idea also, Awani. Okay, boleh, no problem. It's good to know that our activity in increasing atau uh, okay. It's good to know that our activity last week helps to influence you to change bits and pieces of your approach in writing notes. Thank you. So yes, I agree with you. The first individual there is Wilhelm Röntgen, a German scientist that discovered X-ray. Okay, a German scientist, a German physicist, to be specific, physicist, yeah. So Henry discovered radioactivity. Okay, very good. And the third one, the third couple is Mary and Pierre Curie. Both are Polish scientists that discovered atau detected apa yang dia detect. Okay, apa yang Mary and Pierre Curie detect atau apa yang Mary and Pierre Curie discovered? Alright, very good. That is a good idea, Ishad. Okay. So for Mary and Pierre Curie, they also discovered radioactive radiation through its ionizing power. They also discovered that uranium ore, using uranium ore, they successfully extracted two different radioactive elements, which are polonium and also radium. Kan? Oh yes. Okay. Alright, I give you another minute to update. So here are some samples from your friends. Okay. If you want to check it out from Nafdi, Umi Najiha and also Awani. Oh, this is too far. Sekejap ya. Saya dekatkan sikit. Okay, so after this we will discuss specifically regarding a few terms related to radioactivity. For example, what is radioactivity itself, and what is radioactive decay, and what are the rays that usually discussed in science fiction kan, alpha ray tu apa, gamma ray tu apa dan sebagainya lah. Alright, so let's take a look at different types of ray ni ya. Okay, so radioactivity defined as a random and spontaneous decay process of an unstable nucleus by emitting radioactive radiation. So radioactive radiation can be alpha particles, or also known as alpha radiation, beta particles, also known as beta radiation, and also gamma ray. If you can take a look at the diagrams provided on the right side of the screen, you can see that as mentioned by the video that we have observed before, the uranium is highly unstable So initially it has 92 protons and 146 neutrons. So by releasing alpha particle that consists of 2 protons and 2 neutrons, uranium form a more stable particle, which is thorium. Okay, for the next one is beta particle. For example, thorium releases electron to form beta particle, forming protactinium. And then finally, cobalt-60 releases gamma ray. So cobalt-60, the nucleus is less stable, but by releasing gamma ray, dia tak ada release proton ke neutron, but by releasing gamma ray, it will form a more stable nucleus in cobalt-60. So let's take a look at radioactive decay pula. So radioactive decay pula is radioactive decay is a random and spontaneous process where an unstable nucleus emits radioactive radiation until the nucleus becomes more stable. So for example, examples of examples of elements that undergo radioactive decay are carbon-14, radon, radium-222, thorium-234 and also uranium-238. So, yeah. Okay. So, let's take a look at a few example of elements here. Based on your understanding, which of these are radioactive material? Okay, there are 7 elements here. Which of these are radioactive materials? Alright, very good. I agree with you. Carbon-14. Yes, radon-222, thorium-234 and uranium-238 are radioactive materials. Carbon-12, oxygen-16 dengan nitrogen chloride tu bukan ya. Okay, very good. Thank you everyone. So kita dah tahu pasal radioactive decay. Now let's take a look at what are the units that are used to measure radioactivity. Ya. So untuk unit to measure radioactivity, the first unit is curie. So each curie, 1 curie is equal to 3.7 multiplied by 10 to the power of 10 decays per second. Decays per second ni dia ada standard unit dia. Sekarang sudah ada standard unit. The SI unit for radioactivity is becquerel atau BQ. So 1 BQ sama dengan 1 decay per second. Kalau tadi kita tengok 1 curie equals to 3.7 multiplied by 10 to the power of 10. Tapi becquerel ni is SI unit sebab dia punya nisbah tu sama. 1 BQ equals to 1 decay per second. So easier to remember lah. Okay, so let's take a look at how, tadi ada yang tertanya-tanya macam mana, what is the methodology used to estimate the atau to conduct carbon dating kan. So the concept used to determine carbon dating, to do carbon dating is the half-life. So the term half-life is the term to describe the time taken for the number of undecayed nuclei to be reduced to half of its original number. So kita tahu tadi, for example, carbon-14 dia alami half radioactive decay. So bit by bit, carbon-14 tu loses its proton, loses its neutron, and then because of that, the mass of carbon-14 decreases over time. So the time taken for carbon-14 tu hilang separuh daripada mass dia atau hilang separuh daripada dia punya subatomic particles. Tadi kita sebut dia release proton and neutron kan. So the time taken for carbon-14 ke atau any elements atau any radioactive materials that undergoes radioactive decay, macam kamu identify tadi, radon-222, uranium-238. So when these substances atau when these radioactive materials lose half of its mass ke, half of its subatomic particles ke, we call that particular duration as half-life. Okay, so separuh daripada mass dia sudah hilang ke persekitaran because of radioactive decay. So let's take a look one sample application here. Okay, for example here, protactinium Pa234 decays to uranium-238 with half-life 5.2 hours. Okay, calculate the mass of Pa234 after 20.8 hours with its original mass of 80 gram. So, kejap ya. Saya share saya punya screen yang similar dengan kamu ya, so that you can see here whenever I wrote something on the slide. So, kejap. Okay. So dekat sini dia bagi tahu half-life dia ialah 5.2 hours. So maksud dia dekat sini, whatever the mass of protactinium, after 5.2 hours, the mass will become half. So sekarang ni instead of just 5.2 hours, the radioactive decay occurs in duration dalam masa 20.8 jam, 20.8 hours. So from 0 hours, at 0 hours, the original mass is 80 gram. So after 20.8 hours, berapa? Jadi dari 0 hours pergi 5.2 hours, ini adalah half-life yang pertama. Okay, this is the first half-life. Okay, so and then we can see the mass of protactinium reduced to half, jadi 40 gram. Dah sampai 20.8 jam tak? Belum lagi kan? Okay, so kalau belum sampai 20.8 jam, kita tambah lagi. Okay, another half-life. Okay, we had added another half-life. So this is the second half-life. The total hours is 10.4 hours and the mass reduced to another half. Tadi 40 gram, so separuh daripada 40 gram ialah 20 gram. Dah sampai 20.8 jam tak? Belum lagi kan? So we added another 5.2 hours. This is the third half-life. Okay, so in the third half-life, the total hours, we can see that the total hours is 15.6 and the mass has already reduced to half of the previous mass, which is 10 gram. Tadi 20, sekarang separuh daripada 20 is 10 gram. And then dah sampai 20.8 jam, belum lagi. So we added another 5.2 hours. Okay, so this is the fourth half-life. So at the end, we have already reached 20.8 hours. The mass is half of the previous mass, which is 5 gram. So the remaining mass of Pa234 is 5 gram. Okay, This is how we calculate it lah. So another way to calculate it is um, apa tu kita akan apply cara nak calculate half life radioactive decay ni dalam slide seterusnya. Jom kita tengok. Okay. Here are two different half-life problems that we can try here. For the first one, the first one is testing you about the radioactive decay of cesium-137, and for the second one, tested you about your understanding regarding the half-life of actinium-226. Okay, let's try this question first. Okay. I would like to show you another approach on how to do this. Sekejap ya. Where is my screen? Wait, Okay. Untuk mereka yang belum lagi ada idea macam mana nak buat, I would like to show you another way to approach this. So since we already know what is the half-life of cesium, so here is another approach ya. So kita tak tahu berapa kali half-life untuk 90 tahun. So what we can do is we find out how many half-life first. So sebab itulah saya buat approach berapa kali X number of half-life equals to 90 years. So untuk tahu 90 years tu berapa half-life, kita just divide sajalah. So this is what I did. So I determine that there are 3 half-lives to achieve 90 years kan. 3 kali half-life baru sampai 90 tahun. So half-life 1, okay, dia start dengan berapa tadi? Dia start dengan 1 gram kan. So half-life 1 dia dah reduce jadi 0.5. Half-life 2 dah jadi 0.25. So half-life 3 dah jadi tinggal berapa? Okay, so here is another approach for the same question. Selain daripada kita buat kita buat garis masa, kita juga boleh buat table macam ni lah. Okay, so there are a few approaches that you can use to solve this particular question ya. Buat table boleh atau buat timeline. Macam many of you, I can see here, many of you uses the approach of timeline approach. Macam Rashdan, Sofia, Nafdi, ramai buat timeline approach ya. Tak apa, boleh. That is a good idea also Nurin, Dora pun, and then siapa ni, Aiman Syamil pun, tak apa, bagus, teruskan. Okay, some of you uses the timeline method, ada juga yang gunakan table method, tak ada masalah. Both are both help you to achieve atau to get the answer. Yes, I agree with you. If you get the answer 0.125 gram, that is a correct answer ya. Okay, jangan lupa tulis unit. So I would like to change this slide. Saya nak tukar kepada student pace so that siapa yang dah siap boleh move on to the next slide ya. Sekarang ni kita tengah buat slide 12. So sekejap ya, saya tukar kepada student pace. Bila saya tukar student pace, mungkin Padlet akan bawa kamu kepada slide yang lebih awal. You just fast forward to current slide. Alright. Okay ya. Kita tengok dekat sini. If you are we are currently on slide 12. So if the Padlet app bawa kamu pergi ke slide sebelumnya, terus skip pergi ke slide 12. And then siapa yang dah siap slide 12, you can go to slide 13 ya. Sekejap. Okay, so Rashdan dah boleh pergi slide 13. Okay, Sofia belum lagi. Okay, Nafdi pun you can go to slide 13, very good. Okay, and then Aira pun sama boleh. Aira, you can go to slide 13, very good. Okay, almost there. Dora jangan lupa tulis unit ya, gram ya. Okay, Barada almost there, very good. Okay, Aiman Syamil, okay, your first question is very good ya. Very clear work. Sama juga dengan Raja Nur Alisha, tinggal nak tulis unit saja, 0.125 gram. Okay, Nurul Alia almost there. Okay, Amita pun almost there. Okay, Putri Dania, you can do it. Okey, kejap. Siapa lagi yang boleh pergi ke next slide ni? Irsyad sikit lagi ya. Irsyad sikit lagi sebab dia punya half-life is 2. Kan? Irsyad nak apa? Question 2 tu. Question 1 tu. Question 1 tu ada tersilap sikit tu sebab dia start dengan 1 gram. Okay Irsyad, mungkin pelik pula kalau sebab miligram ya. Sebab you converted to milligram ya. Okay. Kita maintain the same unit ya Irsyad. Okay. Lepas tu Irsyad yang soalan kedua tu half-life ada 2. Half-life 1 29, tambah lagi 1 half-life baru sampai 58 miligram. Baru sampai 58 jam. Jadi sebenarnya berapa? Lepas 58 jam berapa? Yang Irsyad bagi tu baru lepas 29 jam. Okay, dah boleh pergi ke slide 13. Okay. Adenin pun sikit lagi, very good. Okay, Nervin did very good. You can go to the next slide. Slide 13, slide 13, sorry, slide 13. Okay, almost there. Okay, saya nak tengok student dekat slide 13. Okay, Rashdan, soal untuk slide 13, jawapan nombor 1 tu betul. Teruskan. Okay. Tengok slide 12 balik. Slide 13 tu ramai yang baru nak figure out. No worries. Apa tak ada? Okay. So untuk mereka yang still figuring out slide 12, here is a sample answer from Nevindit. Nevindit dia guna approach timeline approach ya. Okay, sangat very clear. The approach used can be understood clearly. Very good. Okay, Awani pun, Awani dah settle, boleh pergi slide 13, very good. Luth Haikal pun boleh, silakan pergi ke slide 13. Putri Dania pun dah boleh pergi slide 13. Okay, Amita almost there, very good. Okay, Alia boleh pergi slide 13. Raja Nur Alisha sikit lagi. Alright. Okay. So kita cuba pula slide 13 ya. Nurin pun dah siap. Boleh pergi ke slide 13. Okay, Aina pun dah siap. Ramai dah siap ni. Okay, very good. Sofia pun dah siap. Okay, boleh pergi slide 13 ya. Siapa dah siap? Okay, so for the second slide pula. For slide 14, slide 13. Okay, untuk slide 13. Okay, slide 13 dia level tinggi sikit. Dia minta kita identify atau determine its half-life kan. So, macam mana nak buat? Okay, Rashdan dia okay, saya share dulu idea daripada Rashdan. Okay, maybe you can get inspired. Okay, ada Rashdan dia guna timeline approach. Itu pun Menarik, betul juga. Okay, so sebagaimana idea daripada Rashdan ni, dia identify dulu nak sampai ke 107.2 tu ada berapa kali half-life. Okay, sama juga dengan approach yang Awan ni cuba buat ni ya. Okay, so both Rashdan dengan Awan ni dia determine dulu berapa kali half-life untuk sampai ke 107.2. Lepas tu so kita tahulah daripada timeline approach tu untuk sampai ke 107.2 tu we have the lead 214 undergo 4 half-life, kan, 4 kali half-life. So 4 kali half-life, so we just divide lah 107.2 divided by 4 equals to 1 half-life is 26.8. Okay, very good. 26.8 minutes kena tulis unit. Okay, hopefully Rashdan untuk soalan 2 tu that is not the end of your answer ya. Ada satu lagi step kena buat. Sebab dia minta mass yang sudah decay, mass yang dah hilang. So mass yang dah hilang berapa? Okay, Nervindik pun, Nervindik pun dah selesai. Yes, you are correct, 26.8. Umi Najihah. Okay, Umi Najihah pun dia dah dapat dah, 26.8. Okay. Bagaimana dengan Luth Haikal? Okay. Luth Haikal pun dah dapat. Okay, good. Nafdik pun sudah dapat. That is cool. Okay. Sangat kemas ya approach yang Nafdik guna. Bagus. Okay, Dora pun sama. Very very clear ya. Very clear. Very clear your timeline ya. Oh, ini timeline warna-warni rainbow pun ada. Umi Najah ada guna timeline warna-warni. No worries, boleh. Okay. So Rashdan tinggal nak tulis unit saja kan, gram. Tapi your answer is correct ya, 116.25. Okay. So Rashdan, you can move on to the next one, slide 14. Tengok slide 14 dulu. Daripada slide 14 tu baru kita boleh buat slide 15 lah. Okay. Slide 14 tu dia punya explanation Okay. So I think for slide 12 and slide 13, the questions are almost similar sebab dia memberikan maklumat yang lebih kurang sama. So saya minta maaf, saya stop student pace dulu, jangan risau. I will change it back to student pace for you to answer Okay, kejap ya. Saya pergi ke slide 14 first. So another way to determine half-life of radioactive decay is by observing a graph of activity against time for radioactive substance P as shown in figure 8.4. So bila kita ada graph macam ni, kita tahu, kalau kita tahu original activity dia ialah 800 BQ. Okay, macam mana kita tahu original activity dia 800 BQ? Sebab kita tengok pada position 0. So at time 0, the original activity is 800 BQ. So at half-life, okay, kalau half-life maknanya half-life separuh daripada 800 BQ which is 400 BQ. So from the graph, we can determine what is the half-life at 400 BQ. Sekejap ya, saya tukar kepada draw function. Okay, sekali lagi saya tunjukkan ya. Okay, please refer to Google Meet ya. Okay, so sekarang ni kita tahu at time 0, kejap ya, saya guna pencil function, saya guna warna hijau ya. At position 0, pada masa kosong, the original activity atau the initial activity is 800. So kita tahu half-life tu pada half-life, saya tak boleh buat macam ni. Kita tahu pada half-life, okay, pada half-life we have to divide by, pada half-life kita kena divide by 2, kan? Kita kena divide by 2. Barulah kita akan dapat what is the half-life activity. Sebab itulah kita tengok pada solution ni, original dia ada 800 BQ, at half-life dia dah jadi separuh, tinggal 400 BQ. So we know already the activity is 400 BQ. So kita tengok pada graph, bila 400 BQ, the position at Y is 40 seconds. Okay. Pada aktiviti 400 BQ, position pada titik X dia ialah 40. So 40 second tu is the half-life for P. So untuk soalan yang sama, dia boleh bagi kamu graph siap-siap and then you determine the half-life, but it can also ask you to produce the graph first. Dia juga boleh minta kita hasilkan atau lukis graph dulu. Okay, so the scale I already given here. So jom kita sama-sama buat dia punya graph. Okay, last kali untuk hari ni ya, kita buat sama-sama graph dia. So at 0 it is 120 and so on and so forth lah. Okay, ya. Okay, kita dah ada student yang dah lengkap dah ada punya scale. Okay, good. Ya, memang 25 tu dekat dengan dengan kepala arrow tu ya. Okay, very good. And then another scale is And don't forget to include the unit for each axis. Okay, let's see here. Okay, boleh plot dah. $120 at 0. Okay. So, most of you have already plotting the graph. Okay, very good. Okay, dah plot graph. So when you plotted the graph, here is a sample of what you can see here lah. So saya share saya punya screen untuk tunjukkan berapa macam mana bentuk graf tersebut, and then kita tahu original activity is 120. So untuk half life kita kena divide by 2, barulah kita dapat half life dia is at 60 kan. So since the half life is at 60, okay, kita tengok dekat 60. Okay, and kita tengok dekat bawah ni berapa nilai yang kita dapat. Okay, so kita akan dapat nilai T and a half. Okay, half life dia kita boleh jumpa dekat sini lah. Berapa. Okay. Alright, so hopefully okay, saya dah nampak dekat situ one of you have already completed plotting the graph. Okay, dari situ kita boleh dapat ya berapa. So anak-anak, it's already 8:27. I have another class with, okay. Oh, is there a way to slow down atomic decay? Is there a way to slow down atomic decay? Tak boleh stop tapi boleh control. Yes, boleh. Boleh control in a sense boleh cepatkan atau lambatkan untuk menjawab soalan Irsyad ya. Tapi it requires more explanation. Hopefully I can address that tomorrow. Okay, apa yang saya nak sebut tadi? Okay, so that is the end of our class for today. So I will change this PDAC into student pace so that you can complete slide 18, slide 18 tak ada apa, slide 19 and slide 20 ya. So untuk student yang belum siap lagi slide 14, 16, 14 and 16, you can do so after this. Lepas tu ada additional work on slide 19 and slide 20, but no worries kalau tak tahu nak buat, kita akan discuss tomorrow don't worries. So up until now, do you have any questions regarding to this activity so that I can address your concerns tomorrow? Ada apa-apa nak tanya tak? Oh sorry. Okay, lepas ni baru saya akan tukar kepada student pace ya. So do you have any question regarding today's lesson? Basically today we have discussed about radioactivity, a bit of an introduction, siapa yang jumpa several concept regarding radioactivity. Kemudian kita discuss mengenai different types of rays, and towards the end tu kita discuss mengenai how to calculate half-life lah. Okay. So tadi kita tengok video pasal radioactive carbon dating kan. So slide 20 and slide 21 are applications of radioactive decay for carbon dating. Okay, nanti boleh tengok ya. Alright, calculation slide 13 ya. Okay, nanti kita address that particular part on Wednesday. How do hydrogen bombs work? That is good. Oh, okay. Nanti esok boleh share ya. I have created a formula to calculate half-life. Okay, nanti kita share. Nanti saya tulis dekat slide ni. Nanti saya boleh include dalam untuk kelas esok. Okay, so sorry, it's already 8:30. Thank you so much for your understanding and your cooperation. I will share the class recording later today, so you can refer to today's class recording later when you do the activity. So that is all for today. Thank you so much. Sekian wabillahi taufiq wa hidayah. Assalamualaikum. Thank you Tiga Solari. See you.
Thank you, teacher.
Thank you,
Thank you, teacher.
Teacher.